is you can't use your calculator on some of these types of questions. Like we'll have them on the quiz and the test at the end of this unit where there'll be like a little separate part where you can't use your calculator. If you want to use your calculator to check any of these problems though as you're doing the homework assignment, that's completely fine. But I'm going to try and do all of these without a calculator today so you can see how to do it. Okay, so what we're working on today is actually just exponent properties again, which we've been doing all throughout this unit. But all the exponents today are going to be what they call rational exponent. Rational is just a fancy word for fraction. So that's all this says at the top, an exponent that can be written as a fraction. So same rules apply. So what we're looking for is like bases. And my very first question, this is literally all you have to do. These are like bases. Both of these are 2, right? So if you are dividing, you just subtract the exponents. So both of those are base 2, and you just take the numerator exponent, subtract the denominator exponent. So just do 2/3 minus 1/3, and we're just going to leave it as a fraction. This would be rewritten as 2 to the 1/3 power. That's all you have to do. Now, if you're multiplying like bases, which is what I have in the second question, we are going to add the exponents together. So 7 to the 1/2, 7 to the 3/8. I'm going to take 1/2 plus 3/8. Now, this is a little different than the previous question. Can I just add 1/2 and 3/8? Like, would you put like 4/10? Everyone's like, no, Miss Birdie, that would be wrong. Like, okay, you guys aren't awake. Okay, what do I have to have if I want to add or subtract fractions? Common denominator, bless you. Okay, now, what would I do to take and make 1/2 have a common denominator with 3/8? Like, what would you do there? Multiply by 4. I would just, if one denominator can go into the other, you might just have to change one of the fractions. So I would just go 4 and 4. This is just like rationalizing a denominator. Whatever you do to the bottom, you got to do to the top of the fraction. That way you're not actually changing the value of the expression. So 1/2 would be the same thing as 4/8, right? Once you have a common denominator, you're golden. Literally just add across the top. Do not change the bottom. This would be 7 to the 7/8 power. Done. Okay. Now, the next question, and this might be something you know, and it might be handy to grab this lovely little yellow piece of paper that you guys have. If you don't have like bases, which I don't have here, right? I got a 2 and a 16. What you want to try to do is rewrite so they're both the same base. So I have 2 to the 1/2. There's not going to be a way for me to rewrite 2. Can anybody think of how to rewrite 16 so it would be 2 to a power? Not quite. If you look here, that's why I grabbed my little yellow piece of paper. Do you guys see how 16 is there? So whatever the root is, yep, 16 is 2 to the 4th. Okay, I'm just trying to do this so I can have a like base. Okay, now, I still had that to the 3/4 power. All right, so power to a power, you're going to actually multiply those exponents. If you have 4 times 3/4, you are just going to take, I'll write it out here, you don't have to write this out, but you're just going to take the numerator times the number. So 3 times 4 is 12, and then you divide by the denominator. 12/4 is actually going to make that exponent into just a 3. Okay, now again, I don't have a common denominator here. So what I need to do is I need to add 1/2 to 3. And if I just have a plain number, I just usually write it over 1 just to give me a space to get a common denominator. What would you do to 3/1 so you could add it to 1/2? Multiply by 2. Okay, so we're just going to do top and bottom by 2. All right, so I'm really multiplying by 1, but 2 is the number you want to use on the top and the bottom. So this would be 6/2. Okay, now 1/2 plus 6/2, just add the numbers on the top. 1 and 6 is 7, keep the bottom the same. If you get a number on the top that's bigger, like I have 7/2, don't change it to a mixed number, just leave it as an improper fraction. So just going to leave it right like that. I got one more like this right next to right next to this here. I got 5 to the 1/3, and then times 25 to the negative 1/3. Do it.
How did you get 3/1 from the 2?
Math.
You said math.
I did say math. I'm just cheesing you. Okay, so I did 4 to the 3/4 power. So power to a power, I'm going to multiply those exponents. 4 times, you don't need a common denominator to multiply, just straight across the top, straight across the bottom. So I did 4 times 3, that gave me 12. And then this would be like 4/1. So it'd be 1 times 4, just be 4. 12 divided by 4.
I got that one.
Gotcha.
Where'd the 2 go?
So 1/2, and then 3. So what I did here, I kind of didn't write out the step. It would be plus 3 times 2 would be 6. 2 times 1 would be 2. And then I have a common denominator there.
I know, but the 2.5 or 2.5 power times 2 to the 3rd power. Where'd the 2 go?
I'm adding these because now they're like bases. I get what you're, sorry, but I wasn't getting what you're saying. These are the same base, so I just wrote 2. What you do there is then just add those exponents. So I just had to take 1/2 plus 3. It's a little trickier, I think, with numbers than it is with variables, which we'll do in a second. But yeah, I'm not disappearing this 2. I'm just saying I'm going to add those exponents together. Does that make sense?
Yeah. So okay. Yeah.
It just says 2. It doesn't change. You don't actually multiply those numbers. People will do that on accident. You just keep it as a 2. Good question. Okay. So again, I'm going to try and create a like base. Can anybody rewrite 25 as 5 to a power? What do you think? Okay. Oh, okay, yeah. Okay, 16 is the same thing as 2 to the 4th power. That's where you're trying to do that. We're going to do this in the next question. So I'm trying to rewrite it so the bases are the same. Then you can apply your exponent properties. Really good. Okay, we're going to do that right here. So I've got 5 to the 1/3 and then 25. Can't apply my exponent properties because I don't have like bases. I have 2 totally different numbers. What I want to try to do is, can you tell me how to write 25 as 5 to a power? 5 to the 2nd. Okay, so 25, I'm just going to, bless you, replace that with 5 to the 2nd. Same thing, bless you. Okay, now that is to the negative 1/3 power. All right, now 5 to the 1/3, that's just that first term there. I didn't change anything. If you do power to a power, you're going to multiply the exponents. So I'm taking 2 times negative 1/3. You do not need a common denominator for multiplying fractions together. So that second term will just be with an exponent of negative 2/3. If you are multiplying like bases, you're going to add the exponents together. So it's not going to turn into 25. It's just going to be 5. And then you're going to take 1/3 plus a negative 2/3, which is actually going to be a common denominator we already have there. So we can go ahead and just add those together, but it'd be 5 to the negative 1/3. Now, negative exponents are not considered simplified, so all I have to do to get rid of that, I'm just going to turn this into a fraction real quick. I'm just going to scooch this to the bottom and move it and lose it, and I lose the negative exponent, and then I'm considered simplified. So I would write that as 1/5 to the 1/3. Negative exponent does not mean negative number. Is anybody having a question? Okay. If you do the question next to this, if you have a negative exponent in the bottom of a fraction, I'm just going to move that up top real quick. And you move it and lose it. If it's negative in the bottom, you move it to the top. If it's negative in the top, you move it to the bottom. So this problem is really 3 to the 2/3 times 27. And then it would now be positive 1/3 when I move it to the top of the fraction. Now, challenge here. I need a like base. So I've got 3 to a power. Could you think of how to rewrite 27? Oh, I thought you were raising your hand. Oh, crisis. It's up on the board, too.
Oh.
What do you think? 3 to the 3rd. I have extra little yellow papers if anybody needs one. I will be more than happy to give you it. Okay. Now, here's my advice on this. I'm multiplying like bases, so ultimately I'm going to add these exponents. Okay, so I have 3 to the 2/3, right? Plus this exponent, power to a power, you're going to multiply. If you actually multiply 3 times a third, those are reciprocals, that exponent would just be 1. However, here's what I would recommend on that question. If I take 3 times 1/3, it is equal to 1, but I'm going to write it as 3 over 3 because that's going to make it easier when I have to add it to the other exponent. So I'm just multiplying like bases. I'm going to add these exponents. It's 2/3 plus 3/3. You have a common denominator, or I don't know, I just wrote 5 there. Don't write that down. You have a common denominator, so just keeps the base the same. Across the top, you're going to get 5, and do not change the denominator when you are adding or subtracting fractions. You want that common denominator that stays the same, so that'd be 3 to the 5/3 power. Is anybody having a question? I did a bunch of ones with numbers. Now we're just going to do a couple of variables real quick. Okay. Now, these are like bases. I don't have to create a like base. I have x and x. So if you multiply like bases, you're going to add exponents together. Problem here is I do not have a common denominator. And in this case, I can't multiply 4 by something to get 6. That would be a nice number. So what I would tell you, we got to change both fractions to get a common denominator. What common denominator would you use between 6 and 4? 12. And so, okay, good. Let's use 12. So I'm going to do top and bottom here by 2, top and bottom here by 3. We're trying to create like denominators here. So 5 over 6 is the same as 10 over 12. 1 over 4 is the same as 3 over 12. And then once you have like denominators, we could just go ahead and add across the top. And this would be x to the 13 over 12. Again, if you get an improper fraction, leave it. Don't change it to a mixed number. You will never see a mixed number exponent on anything. So just leave that as 13 over 12. Okay, I'm going to do one more. Now, this has some numbers out in front of the x's. You can actually multiply these numbers together. So 8 is not being taken to that power. 10 is not being taken to that power. So it's just the x's being taken to the power there. Just do 8 times 10. This is 80. I don't know why I just wrote 8. 80. And then x. Now multiply the numbers. You're going to add the exponents on like basis. So this would be negative 1/6 plus 5 over 6. We already have a common denominator there, so it's not too bad. So negative 1 plus 5. This would be 80x to the 4/6 power. Just the x is being taken to that power. And the only thing I would say to you there, if you do get a fraction that you can reduce, go ahead and do that. So 4 and 6 are both divisible by 2. So this would be 80x to the 2/3. Is anybody having a question? Yeah. So I didn't have any numbers in front of, like this doesn't have any numbers in front of the x's. These are actually the 3 and the 27, those are actually the bases. So you're just changing it's a little bit easier if you don't have a fraction exponent. But like if I did, 3 to the 1st times 3 to the 4th, you don't write 9 to the 5th. This would be 3 to the 5th here. So it's always tricky with the numbers, but you don't multiply the numbers. In this case you do, because neither one of the 8 or the 10 are being taken to an exponent, just the variable is. That's a really good question. Does anybody else see any question they want to look up? Okay, now, I promise this is not hard, but again, you're not going to be able to use the calculator on some of these problems, and I think that little yellow sheet will be very useful to you on these particular questions. So, I'm going to take it from having a fraction exponent to being a radical. All right, so here's the easiest thing I have ever learned to remember this. I just call it bottom out. All right, the denominator or the bottom of the fraction is going to become the index of the root. So x to the a over b is equivalent to the b root of x to the a power. So bottom out, the bottom of the fraction becomes the index of the root, and then the power is going to be whatever the numerator is. These two pieces of notation are the same. You can write it as the b root of x, and then all that to the a power. Those two things are equivalent to each other. I would tell you when you're actually doing the problem, especially with numbers, I would take the root first and then use the exponent. We're going to do that in these questions underneath here. and I promise they're really quick. They will all be nice numbers if I'm asking you to do this, because I'm asking you to do it without a calculator. But you might want to use that little yellow paper, especially if we're doing like a cube or a fourth root or something like that. So 64 to the 1/2. All right, if I do that bottom out, this would be the square root of 64 to the 1st, which is really just the square root of 64. So 1/2 power is the same thing as the square root, and then you all know the square root of 64 is just 8. So that's literally all you have to do. I would take the root first. In that case, it's just the square root. 64 to the 1st is just going to stay 64. So 1/2 power is the same thing as the square root. If I do this one, bottom out, this is the square root of 4 to the 3rd. So I would do the square root of 4 first. So square root of 4 is 2, and then you take that to the 3rd power. And all you have to do there, if you want to look at that little yellow paper, or you might already know that, but 2 to the 3rd power should be 8. But take the root first. All right, now negative 1/3 power, all that means is we're going to have a fraction. It does not mean a negative number. We're just going to take, and I'm going to rewrite this so I don't have a negative exponent. This would be 1 over 343 to the 1/3 power. All right, so if I do my bottom out, this is 1 over the cube root of 343 to the 1st. So 1/3 power is the same thing as the cube root. Anybody know cube root of 343? It's a nice number. 7. So this one would just be 1/7. Okay, now I have one more. This is a negative number, not a negative exponent. So I'm going to do bottom out. I'm going to do the cube root of -8, and then I'm going to square that. Do the cube root first. You can take the odd root of a negative number. What would the cube root of -8 be? -2. Okay, now this is super tricky here, but you got to be careful. All right, then I'm going to square that. What do I get if I square -2? That becomes good. This becomes positive 4. -2 times -2 is going to become positive 4. Is anybody having a question at the moment? I know, we'll do smart, don't worry. These are tricky, I know that. All right, there's a couple questions that maybe instead of writing the exponent as a fraction, they might give you a decimal, which I have a couple examples up here at the top, but this is the same type of question. If you have a decimal, you want to convert it to a fraction real quick so you can do bottom out. Okay, 1.5. If you're like, I don't know what that is as a fraction. Easiest thing I can tell you to do, this is 1 5/10. So the tenths place means I can write this would be 25. You could do 15 over 10. Just drop the decimal. If you got it in the tenths place, just put it over 10. So it'd be 15 over 10. Now, I would not be like, hey, let's take the 10th root of 25 to the 15th power. Reduce the fraction first, okay? So 15 and 10 are both divisible by 5. So this is really 25 to the 3 over 2 power, and it won't be as bad. Once you get that, I'm going to bottom out. So this will be the square root of 25, and then we'll take that to the 3rd power. So what's the square root of 25? What's 5 to the 3rd?
Is the denominator?
The denominator becomes like the index of the root. Whatever the...
If it was like 3 to the cube.
Exactly, exactly. Like the next one will be a 4th. Okay. Anybody know 5 to the 3rd? 125. Done. All right. All right, so 16. I'm going to bottom out. All right, 16 to the 3/4. This becomes 4th root of 16 to the 3rd. All right, I don't know how familiar we are with this. Does anybody know the 4th root of 16? 2. All right, so this 4th root of 16 is 2, and then I got to take it to the 3rd power, so then that will be 8. All right, if I have 0.8, that's 8/10. So this is -32 to the 8/10 power, which I would definitely reduce, and that's going to be -32 to the 4/5 power. Okay, trying to do these without our calculator. So I'm going to bottom out. So this would be the 5th root of -32, and then we'll take that to the 4th. I know this one's not super common. Does anybody know 5th root of -32? is -2. All right, so 5th root of -32 is -2. Now, I have a -2 being taken to the 4th power. If you've got a negative to an even power, that negative is going to get canceled out. This should honestly be +16 when you're done. So you don't want a negative for the answer there because that 4th power is going to cancel that negative out. Okay, now I got one more. Power to a power is multiply the exponents. So this is 216. 2 times -1/3 is -2/3. Negative exponent does not mean negative number. It just means we're going to turn this into a fraction real quick. So I'm going to write this as 1/216 to the 2/3 power. So I'm just going to have a fraction as the answer. If I do my bottom out, I'm going to do cube root of 216 squared. Does anybody know cube root of 216? 6. Okay, so cube root of 216 is 6, and then we got to square that. So my answer here should be 1/36. Sorry. Okay. Now I know it looks like there's a lot more problems here. We're just going to do these real quick. So I'm literally just asking you to change these from exponential form to radical form. So radical form means you have a root of some kind. You're not going to have to do much here at all. Just bottom out. So 1x to the 1/2. This would be the square root of x to the first, or you'd typically just see that written as the square root of x. 1/2 power is the same thing as the square root. 1/3 power, x to the 1/3, if I do my bottom out, this would be the third root of x to the first, or just cube root of x. You don't have to write that first power, but 1/3 power is the same thing as a cube root. If I do x to the 3/4, we're just going to bottom out there too. 4th root of x to the 3rd. I would need to leave the 4 and the 3 there. That doesn't simplify. That would just be my answer. And then we're going to do a couple more of these real quick, and then I'll be quiet. Now, this one. This is x to the 3/2. Now, with a variable here, this is the square root of x cubed. If your exponent is bigger than your root, you should be able to remove maybe a perfect square, perfect cube, perfect fourth, whatever you're working with. We're working with a square root here. So I want to rewrite this to remove any perfect squares. So I would think of x cubed as x squared times x, just real quick. That's still x to the 3rd, but I'm just trying to remove any perfect squares that I can. So I'm going to pull this out as an x out in front. So you can simplify that a little bit in radical form. This would be x times the square root of x. So if your exponent is bigger than your root, you can simplify it a little bit. Okay. I'm not going to do all of these here. We'll skip this one, but these real quick. If you do a product to a power and power to a power, I got to multiply both of these guys by 2/3. So 5 times 2/3. You're just going to do the number times the numerator. So 5 times 2, this is 10/3. And then b to the 7th, 7 times 2, it's just going to be 14/3. That exponent is going to change on the top and then the bottom. Okay, now, I'm going to rewrite this. I'm going to bottom out. They're both under a 3, so this is going to be a cube root. A to the 10th, b to the 14th. Again, this ends up being a little tricky because my exponents are both bigger than my root. So just want to remove any perfect cubes here. So I would do a to the 9th times a to remove perfect cube, and I would be doing b to the 12th and b squared. Okay, that's going to let me pull out a cubed. Just divide your exponent by root. This is a little review from a little earlier on. And b to the 12th is going to come out as b to the 4th. So out in front there, I'm going to have a cubed b to the 4th, and then cube root, just one a left there, and b squared. And I'm just going to do one more real quick here. Oh my goodness. Actually, let me skip the next one because I want to show you how to do the last example real quick here. This is just reversing what we just did. Just reversing. So changing it from radical form to exponential. So if you do bottom out, the index of the root should be the denominator of the fraction. Like this will be c to the 3/4. This will be b to the 5/3. Hopefully that'll help you guys enough because we're going to run out of time here. I'll go back and finish some of the other ones later.